Hello everyone, welcome to the fourth video. I'm Liang. So last time we learned how to do the general operation with those functions, and also we learned how to add a solution. So in today's video, I'm going to teach you how to use uh, these three parts: the mix, the reaction, and the equilibrium phase. And before we start, just a kind reminder. So if you feel confused with what we are doing now, like how did I open this interface? Why it becomes that? So I would strongly suggest you go back to previous video to review what we did. So let's begin. And let's start with mix today. So what mix means? So the mix, it means sometimes we have several solutions and we want to mix them together. So then we need the mix to mix them together. And how do we do that? So you can look at here. So normally all the solution you defined it will shown here. So if you define it 3 or 4 or more, you can see them here. And if you click it, you can see it on the right side. So the key point is just be aware what's the meaning by this mixing fraction. The mixing fraction, it means like how much solution are we going to add. So take an example. Let's look at this formula. So it's like uh, how much elements you have in your solution multiplied by the fraction is how much you're going to use in the mixing. It's a little complex, but let's take an example. For example, in my solution 1, you can see there's 1 moles uh, calcium. Is that clear? And in my solution 2, there's 2 moles of sodium. So now, if we take the mixing fraction as 2, take the mixing fraction for second solution as 0.5, what will we have after we mix it? So in this new mixture, we will have 2 moles of calcium and 1 moles of sodium. So now I hope you understand what's the fraction works. And that's all for mix. If you feel confused, please replay this part just until you're clear. And next, let's move to the reaction. The reaction is like we already have a solution or a mixture, and now we want to add some new components to see what will happen, what will react, what will. And uh, so you can see here, you need to select what you are going to add into the solution or the mixture. Just for example, we add calcite. We add something more. Uh, and also be aware, you can see for some components like this carbon dioxide, it has a G on the backward, so it means this one is a gas phase. It's gas, it's not liquid. Just be aware when you are selecting this. If someday later in your maybe case study or your coursework, just when you find something new, you want to make your own design, just think about this. And now another thing is that, so let's move to the second page, the reaction amount. You can see it has a linear step, the reaction step. What does it mean? Yeah, so for this part, the reaction amount, it means how much how much components you are going to add into your solution or a mixture. It means how much new component has been added. For example, if I set as 1.2, That means we set a standard value as 1.2 moles of some new things added. But why did I set it's a standard volume? It's standard value. It's because we can see we have a relative stoichiometry here. So that is like a kind of fraction. For example, if we set this at 0.5, so finally what will we got in total? The value is 0.6. It's because we need to use this value to multiply by this value. So it sounds same as the mix, the fraction we used in the mix. So it's like the total, the standard value multiplied by the fraction. So if we add another thing, for example, this one, and we set it 1, so what does that means? So that means we adding two materials for the reaction, and for the calcite we have 0.6 in total. And for that one, we have 1.2 moles in total. And both of them will be added. And finally, how about the step? The step means we divided our total amount of new components into 3 steps. So once again, take an example. If we think about this one, this new one, so we have 1.2 moles in total going to be added, but we have 3 steps. So that means we have 0.4 moles in each step. Hope that clear. If it's not clear, just repeat this part. Anyway, so afterwards, the list of steps. So this one is relatively easier because you can set the amount you're going to add for each step hand by hand. For example, we set 0.2, 0.5, 0.7. So that means how much are you going to add in each step. So this time we don't have such like a total amount of new things. So it's just give a value for each step. And finally, be aware of your units. Yeah, just don't forget to check your unit. And also before we end, there's also another thing you need to know. So it's same as when we defining the solution. You can double click to find what you want here, and also you can type what you want as you wish. This is also acceptable. And that's all. So finally, let's move to the equilibrium phase. So for this phase, some people will feel confused, like, I know what's reaction. I have learned chemical maybe in my high school, but I'm maybe not very clear with the equilibrium phase. So the equilibrium phase is like, think about we have a bottle of water, we add some salt in there. So the salt will dissolve into the water, but if you add too much, not all of them will dissolve. And sometimes if you boil it, it may dissolve more. If you cool down, it may dissolve less, or some salts will no more in the solution. So it sounds like this. Uh, and the things you need to pay attention is that, so the first is what are you going to add into your solution. Just for this time, we selected calcite, but in the future, for your personal program project, for your case study, for example, I choose a land. I search the land, the condition was underground, the sand is different, the soil is different. So you may use another kind of mineral that's depend on you. So first, pay attention to this. And second is the saturation index. So I'll give you a simple introduction about saturation index. So it's a value that calculated by a very complex process. But anyway, what does it mean? So when the value is 0, is perfect balance. When it's over, when it's positive, it means it's super saturated. So it sounds like it contains more minerals than its ability, its capacity, I mean. And if it's negative, that means it's under, so it's not saturated. In our case, I would suggest you just use 0, but just let you know what are we doing. Just clear off what are we doing. And finally, for this amount, the amount here is like how much, just as the example I mentioned, how much salt are you going to add into the water, into the bottle of water. Uh, you just set it as a very high value because normally not a lot of calcite will dissolve into the water. So just set it as a very high value, it doesn't matter. And just use the default value, and that's all for our equilibrium phase. So now we have finished these three functions. Afterwards, if you are ready, you can click here. You can see there's a run here. And after you click that, you will see this pop-up window. It's like you need to set up your input file, your output file. It's like it will save your input file and your output file. If you don't save your input file, then don't allow you to run this program. So just find a place to save it. And if you are using our university computer, I would strongly recommend you to use OneDrive to save this kind of document because you can use it in your future. Maybe also it can benefit your coursework. And afterwards, it will ask you to because it's creating a new file, so it will ask you to replace the old one. You just click yes and dismiss. So this output file is our result. And because this video takes too long, so in next video, I'm going to introduce, tell you how to read this output file, and also what's the key point when you're reading this file. And well, there's one more thing before we end this video. So just think about in this part, we only defined it our solution. We only defined it what's are going to add as a reaction source, but we didn't define it how do they reaction. But why the software know how to do that? It's because the database. So the software has already been defined it as it has a database. It has a lot of like formulas. It has a lot of values, a lot of data there. So the software with the database, the software knows how to do the calculation. So that's why we don't need to do the define. In the future, if there will be some case like it's not included in the database, so we may need to define something by ourselves. And but that is a advanced content, so you may learn it later, but not this time. So just let you know that. And so there's nothing left. I think this everything for today's video. And yeah, that's all. Okay, see you next time.